Good morning, students. So I hope all of you understood the last question number 7 from the exercise 6.2 chapter triangle, isn't it? So here today we discuss the next one, question number 8. And if you see, the question is given here using theorem 6.2. That means now here we have to use the theorem 6.2. That means the converse of Thales theorem. And what is the converse of Thales theorem? If the two sides divided in the same ratio, that means the line segment parallel to the third side, isn't it? So now this one is the converse of Thales theorem. So that's why using theorem 6.2, that means the converse of Thales theorem, what we need to prove that the line joining the midpoints of any two sides of a triangle is parallel to the third side. So if you see the diagram here at first of all, if we consider a triangle, and the triangle is this one, you see here, the triangle is A, and here we consider B, and this one is C here. And in this triangle, so midpoints of any two sides, so any two sides, first of all we have to consider, suppose here we consider this side and this side. Is it clear? These 2 points are, if we denoted by P and Q, so if we join these two, then this PQ is the line segment here, and the most important part is what? The midpoints. That means this P and Q both are midpoints, first of all, remember. So here this P and Q both are midpoints according to our question given. And what we need to prove here now? We need to prove this line segment PQ parallel to the third side, which one is BC. We need to prove here PQ parallel to BC, we need to prove here. Is it clear? So now let's see here what we have to do. First of all, here we have to write consider the given figure. So that's why here you have to write consider the given. So this one we write consider the given figure. So if we consider the given figure here, if we consider the figure, so PQ, according to your question, PQ a line segment. So in which here you have to write in which PQ. So the line segment here we consider first PQ, in which PQ is a line segment. So this one we write here line segment joining the midpoints. So line segment joining the midpoints. Joining the midpoints, and the midpoints are here we consider P and Q, isn't it? So joining the midpoints P and Q on sides, which are the sides here? First one is AB, and another side is AC respectively. AB and AC respectively. This one. So here what we consider, according to our statement, here we consider on this side AB, P is the midpoint. The meaning is that on this side AC, Q is the midpoint, and PQ is what? The line segment. And now here what we need to prove? We need to prove this PQ parallel to BC, we need to prove here. Is it clear? So at first of all, you see here, since P is the midpoint as well as Q is also midpoint. So if P is the midpoint, that means the distance of AP and PB are what? Same. Similarly, Q is the midpoint. So that means AQ and QC are same, isn't it? So that's why at first we have to write this one. Since here you have to write P is the midpoint. Since P is the midpoint, that's why here you have to write. Therefore, you have to write here AP by PB. So this one we have to write AP by, if you write AP equals to PB, because their distances are same. Since P is the midpoint, so that's why their distances are same. So that's why we write AP equal to PB. And if you cross multiply this PB, then here you have to write AP by PB equals to 1 if you cross multiply this PB. So we put this one is equation number 1. Is it clear? Similarly, another midpoint here we consider, and the second midpoint is Q here, isn't it? So if Q is the midpoint, the same process, AQ and QC are what? Their distances are same. So that's why second one we have to write here. Again, here you write. Again, Q is the midpoint. So here you have to write this one is Q is the midpoint. So here we have to write Q is the midpoint. So therefore, you write here, therefore what we write here? AQ equal to QC. So that's why here we have to write this one is AQ equals to QC. If we cross multiply now QC here, then what we get? The result we get here, AQ by this one we get here, QC. We put this one is another equation and this one we write equation number 2. Is it clear? So now here, if you compare equation 1 and equation 2, so in the first case we get AP by PB equals to 1, as well as the second one we get AQ by QC equals to 1. So if you compare these two, so that's why we have to write, therefore from 1 and 2. So if you write from 1 and 2, if you write from 1 and 2, if the right hand sides are equal, that obviously the left hand sides are also equal. So that's why here you have to write AP by PB. So AP by PB is equal to what? AQ by QC. So that's why here we have to write this one is AQ by QC. Now one thing you see here, AP by PB equal to AQ by QC. So where is AP? AP is this one. AP by PB is equal to AQ by QC we get. So easily we can apply here the converse of Thales theorem, because according to our converse of Thales theorem, what? If AP by PB is equal to AQ by QC, then this PQ is always parallel to BC according to our Thales theorem. So that's why here you have to write by using converse of Thales theorem. By using converse of Thales theorem, we obtain. By converse of Thales theorem, we obtain what we obtain? Here the ratios are equal. That means here these two sides are, these two lines are parallel. So that's why here we have to write PQ is parallel to BC. Isn't it? That means these two are parallel here. Is it clear? If these two are parallel, then our proof is here complete. With the help of this converse theorem, we prove this one. Is it clear? I hope all of you understood. If I repeat one more time, if you see here, from equation 1 and equation 2, their ratios are equal. So that means AB by PB equal to AQ by QC we write. So this one we write. So if you check out this one in our figure, so AP by PB is equal to AQ by QC. So if the two sides are divided in the same ratio, according to our converse of Thales theorem, the line segment, whatever we join through these points, so line segment is always parallel to the third side. So that's why here PQ is parallel to BC. I hope all of you understood. So here another two questions are remain, question number 9 and question number 10. So in our next class we have to discuss the question number 9. Is it clear? Okay, thank you.